Thanks for coming today. My name's Brett Statham. I'm a Microsoft technical evangelist based in San Diego, and appreciate you giving me your time here today. What I was going to talk about today is a technology that we've been talking about a lot lately called IoT Edge. Is anybody messing around with IoT Edge right now? Okay, a few hands. All right, cool. Anybody just doing IoT in general? All right, good, more hands, awesome. So this is the right place for it. We're at an interesting point in time because we're just on the crux of a new public preview of a new version of Azure IoT Edge. And so when I submitted this talk back in the summer, I didn't know that was coming, but we're getting pretty close to a new public preview here, at least before the end of the year here, we expect. So that said, though, everything that I talk about here today is still conceptually perfectly valid. In fact, you'll find that if you've been working with Azure IoT Edge as it is now, what I'll call V1, typically the code that you write is going to translate right across over to V2, at least in terms of the core code itself of how you communicate with your devices and how you perform whatever analytics or filtering or manipulation of the data coming from them happen to be in V2 as well. What V2 gives us really is a much nicer deployment model, a much nicer configuration model, and we'll come back and talk about that a little bit at the end here. So with that said, I'll start out just sort of a really quick overview of the Azure IoT stack, and then I'm going to jump in and do some demos around IoT Edge V1. And we'll talk about how you can go about getting IoT Edge V1 down onto an edge device, some of the different ways of creating modules and getting them running and getting sensor data up into the cloud. And then, like I said, at the end of this, I'll come back and just sort of touch on some of the new things that we expect to be coming down the pike with the IoT Edge V2, again, for lack of a better name. So the Microsoft Azure IoT stack is really just a great way to get data, typically from sensors in the field, into Azure. And once you get that data into Azure, well, now all of the rest of Azure just sort of opens up there for you. So in the Azure IoT stack, sort of the heart of an IoT solution is IoT hubs. And IoT hubs is really just about being able to get data from sensors up into the cloud and then being able to get message or configuration or manipulation from the cloud back down to the sensor or back down to the device. Right, so we're going to have some devices in the field. That could be, I know it looks like an Arduino there, but they could be microcontrollers, they might be full-fledged computers, they might be legacy machines that are speaking on protocols like CAN or Modbus or that kind of stuff. But basically the idea is we've got some devices. Those devices are typically going to have some sensors. So sensors are helping us capture, obviously like the temperature and humidity and all that good stuff, motion, position, whatever else we want. And we might also have actuators. We might have ways of having that device actually go do something for us, like turn that motor on or turn on that relay to enable some device or something like that. So we've got those devices out in the field, and then they're going to communicate with our Azure IoT Hub using a set of standard protocols. That could be AMQPS, which was sort of our initial go-to protocol, MQTTS, and HTTPS. And I'm always very particular about putting the S's on the end of those protocols when I talk about them because Azure does not allow insecure communication with it. You must encrypt the traffic as you communicate with the Azure IoT Hub. And that can that's great from a security perspective. That's what we should be doing. But it does cause a certain impedance mismatch on certain devices, like a basic little Arduino Uno just doesn't have the oomph to do the cryptographic stuff necessary for the TLS and SSL protocols. So up on the other side, then, we've got our Azure services. These could be compute services like Azure Functions or databases like Cosmos DB, cognitive services in AI, BI services like Power BI and all that kind of stuff. And those services then can, once those messages from the sensors have made it up into the cloud, turn around and consume those those messages via either some direct piping that we have built into some of those services or through a collection of standard APIs and SDKs for multiple languages. So Azure IoT Hubs then is really just sort of that gateway to getting your messages into Azure. And once they're there, then all the rest of the Azure platform opens up to you. So this is, in fact, I think, somewhat of a dated diagram of some of the services that are available up in Azure. And down here underneath Analytics and IoT, there's my little IoT Hub service, right? But once I get my messages into IoT Hub, I certainly have the ability to go communicate with the other IoT-related services like Stream Analytics and all that kind of stuff. But I can also now all of a sudden get data out to all of these other great services, right? So it's just sort of this gateway drug into Azure. So IoT Hubs, again, will be core to how you deal with IoT in an Azure environment. There's tons of great examples and SDKs for various languages, and the documentation is all up there online. So take some time, get in, work through some of the samples, and give it a try. All right, so Azure IoT Edge v1. The reason we need Edge is because not every device can connect to the internet, right? So I've got here some of these little TI sensor tags. It looks just like the picture on the screen. These are cool little devices from TI. They're just sort of a little reference solution that's got some BLE support built into it, and then a bunch of other sensors, temperature and humidity and light sensors and accelerometers and buttons and that cool stuff. But it only talks BLE, right? There's no TCP/IP stack on this. The processor actually probably could do the SSL for me if I wanted it to, but it doesn't have any way to build the pipe to get the messages up to the internet, right? And so that could be a problem, is that not every device can connect to the internet. I also mentioned this earlier with those S's at the end of those protocols. Not every device can do the encryption that's required to participate in secure communications with an Azure IoT Hub. So a great example is the Arduino Uno that everybody likes to play around with and prototype. If you were to actually build a product off of that, it just doesn't have the ability to directly communicate with an Azure IoT Hub. So field gateways then are sort of the solution to this problem, and it's a common solution across sort of the IoT industry. We take those devices, we could have one or many of those devices. They want to communicate with the Azure IoT Hub, but since they can't do it directly, we stick a field gateway in the middle. And then the field gateway is responsible for using local protocols. It could be hardwire USB or OneWire or CAN bus or Modbus or that type of stuff, BLE, Wi-Fi, whatever. And then that gateway then turns around and effectively proxies those messages and that communication over the AMQPS, MQTTS, or HTTPS that Azure IoT Hubs requires. So now, in fact, in that diagram, the gateway device that I have sitting there is an Intel NUC. That's just an Atom processor-based machine that you can purchase from Intel. There's lots of other manufacturers that have gateway devices out there. I brought one in that I was hoping to use in my demo today, and then I was mentioning earlier I forgot my HDMI cable for it, so I couldn't find its IP address. Oh well. But that's this guy here. This is a Dell Edge gateway device, and you'll notice if I come down and look at the interfaces for it, if I can get it to focus, but there's RS-232 and CAN bus, RS-485, and then just good old Ethernet and USB and all that good stuff as well. And of course, on the flip side, it's got Wi-Fi and GSM connections and all that kind of stuff out here as well, right? So this is an example of sort of a hardened device. If you look at all the ports, they're all covered up with things to prevent moisture, dirt, and dust, and things like that from getting into them. It'll mount on standard rails that are typically on a shop floor, that kind of stuff. It supports backup power supplies and just a whole bunch of other stuff that you would expect from a device that could be sitting out in the field far away from maybe the person that has to physically maintain it. So we want these guys to be rugged and to last. Flip side, what's running on that is just Linux. I just put Ubuntu on it. You can run various distributions of Linux and that IoT Edge supports. And so the other example is just this guy over here. It's just a Raspberry Pi hooked up to a little touch screen. And Raspberry Pis are a great way to prototype your IoT Edge configurations, because it's just Linux. And you can, it's got BLE and all that kind of stuff. And you can typically get shields for the other buses and all that kind of stuff if you want to play around with those. But it doesn't have to be just for prototyping. The Raspberry Pi Foundation has, pardon me, get back to my slides here, has a Pi Compute module, which is basically all of the compute functionality of the Pi without all the specific hardware interfaces of it. And so you can actually build products around the Pi compute module, and there's a company called MyPi that has done just that. They have a ruggedized Pi solution that has built-in support, or at least well-engineered support for things like Modbus and CAN bus and LoRaWAN and Wi-Fi and BLE and all that kind of stuff. Again, in a package similar to that Dell device there, where it's ruggedized, ISO certified. You know, you can stick it in a negative 20C environment, and it's going to be just fine and run along happily there for you there. So you don't have to feel bad about prototyping on the Pi. That is actually a path to production if you chose to go with those types of field devices. So the typical IoT pattern then is that, like I said, we've got some things out there in the field. They could be sensors and actuators, et cetera. We've got insights that we want to get from those things. And then we have actions that we'd like to take based on those insights. So for example, if the thing is telling me, hey, I'm a motor and I'm getting it over temperature, the action might be to send it a command back down that says, well, why don't you turn yourself off or slow down or turn on the cooler or something like that, right? And so the insights and actions are better served if they run in the cloud, because then I can have a bunch of things talk to them and I can get to them myself. And so I need those things to be able to send telemetry data up to my engine that's going to capture the insights. Insights get passed along, trigger actions, and then those send commands and things back down to the device. The problem with that is that round trip could be catastrophic. If you watch Sam George's build demo, this is now build prior to last, he had an example of a CNC machine running on a shop floor, right? It's actively cutting a big chunk of metal. And if that CNC were to report back that maybe it's detecting some wobble in the collet or something like that, if we don't shut that down immediately, that machine, the part could break. It could break the tool. It could break the CNC machine, or worse, we could have a safety situation where that tool flies off of the CNC machine and ends up hitting somebody on the shop floor. So if that communication that says, hey, look, I'm wobbling, and then the insight goes, oh, look, that looks like a wobble, and the action goes, well, I guess I should tell it to stop or to turn off. If that takes too long, it could have already become a catastrophic failure. So we have to cut that latency down. So having the ability to capture those insights and invoke those actions closer to the device is really important, right? And so if I were to go put an edge device down, sorry, that's with the cloud gateway, I can now pull those insights and actions down to a device that's closer to the thing itself and cut down on that latency. I also have the ability to do things and say, well, I do want to capture certain telemetries from that thing, but I don't need to capture all of them. The insights and the actions might need all of the detail, but from a reporting perspective, do I really have to know what the RPMs on the motor were every 30 seconds or every 5 seconds or every 1 second? Typically, we don't need to know that. So we can cut down the amount of data that we have to ship up to the cloud, the amount of data that we have to report on, all that good stuff. So what runs on that gateway device then? That's what Azure IoT Edge is. Azure IoT Edge is the solution that we have to help you install it on that gateway device and give you a framework for running those insights and actions and filtering and telemetry proxying and all that good stuff. So currently Azure IoT Edge is in sort of, as I called, the V1 state. You can get it from GitHub. It's open source. It was previously called our Azure IoT Gateway SDK, and then got rebranded to IoT Edge. But it's there. It's open source. It's a ANSI C99 compatible chunk of code that you can now download and compile on the platform of your choice. Because it's ANSI C99 compatible, then you ought to be able to compile it on just about any machine. So there's a bunch of CMake scripts in there that you can use, you can download, build your tool chain on your machine and compile it, and you can run it on Windows or you can run it on Linux or whatever, wherever you want to. If you don't want to have to mess around with that C99 stuff, though, there are some packages for various platforms like Node.js and Maven for Java, NuGet for .NET, where you can download the pre-compiled gateway engine and then write modules that do all the things that you want to do in maybe a little more comfortable language for you. So if you're a C# dev, you can write them in .NET Framework Full or Core. You can do Node.js modules if that's where you prefer to be, et cetera. So there's a number of packages that you can use for those different programming environments. And I'll show you one of those. So a simple example would be, on my gateway, down at the bottom on this slide is this internal message broker. It's called Nano Message. It's this internal messaging pipeline that the gateway itself runs. So that's actually a service of the gateway runtime. When you spin up the gateway runtime, it's going to build this message pipeline. And then you're going to tell it, here's the modules that I want you to come pull up, right? And those modules would typically be the ones that are going to go communicate with your device over USB or over Wi-Fi or BLE or Modbus or whatever it happens to be, using the protocols that the devices speak. And then you might have another module that helps take that data and maybe filter it. Let's only send certain messages. Or you might reformat it. Maybe I want to publish it as JSON, but it's coming in as binary or vice versa. And then finally, a module that sends it up to the cloud. Up into Azure IoT hubs. And so you get to tell it what modules you want, and then you get to set up the communication between those modules. As a module sends a message, which other modules receive those messages. And so you just sort of build your little messaging pipeline. Well, so a real simple sample here would be to have just my gateway platform running. I pull up a module called Hello World that does nothing but spit out a message every so often that says, Hello World, and that's it. Right? And then another module that listens for those messages and does nothing but dump them into a text file and log them, right? So there's actually no cloud communication at all inside this. And so to save time here, again, I've got my Pi running. So this is the same Pi that I was pointing at. Here I'm just VNC'd into it. But rather than even mess there, I'm just SSH'd into it, right? So here's my Pi running over there. And if I were to go list the directories on it, I've already pulled down. Why am I not seeing it? IoT Edge. There we go. So that IoT Edge is the clone of that GitHub repo that I said is up there in Git, right? So you can come clone that down. And if I were to CD into IoT Edge, there's all the good stuff in there. Now, it's not that much fun to work with it from the command prompt. So the other cool thing that I like to do on my Linux boxes when I'm working with them is install Samba. And Samba is the SMB protocol implementation for cross-platform for Linux and Mac. And that allows you to use window file share to communicate with the Pi. So over here in my Explorer, I'm just using the IP address on my Pi, which is 192.168.1.3, in through root share into the home folder, and I'm now looking at the folder structure of my Pi user. And if I come down and look at IoT Edge, that's that same folder that I was just looking at there. And now the cool thing is that I can turn around and open this up in something like VS Code and have a nice code editing experience locally on my laptop, but I've got Pi or the IoT Edge running over on the Pi. And the other cool thing, when I hit save, it's saving there, right? So it's just normal Windows file share stuff at this point. So we'll get this guy to open up. And if I scroll down into the samples folder, so this is that repo that I just cloned down from GitHub of the gateway, IoT Edge gateway. And if I come down to Hello World, underneath the source folder, you'll notice a couple of different configuration files. And since I'm running on Raspbian, which is a Linux distro, I'll look at the Linux configuration. And so what you can see in here then is that this configuration file is pretty simple from a structure perspective. I tell it what modules I want to load up, and then how those modules are going to communicate with each other. And so this one only has two modules. I've got one called Hello World, and it's going to go run the module from here, and I'll show you the source code for that in a second. And another one called Logger. That's this module. This is the actual implementation, so it knows how to log. And then this is the arguments or the configuration of it, and this is telling it where to log. So it's going to log into a file called log.txt. And so if I were to actually come down and look at the source code for this module, that's up underneath the modules folder. There's Hello World, and I can open up this module. There's the C code for it. And so a module, remember, is really just going to be sending and receiving messages from that message pipeline down below. And then when it gets a message, it's going to do something with it. And then if it needs to, it can send the message back out down to the broker. Well, in this case, we don't actually receive anything. We just emit. We just publish. I don't care what anybody else wants to tell me. I'm just going to keep saying hello world, hello world, hello world. So this guy basically has a method in it, which is my hello world thread. And what this guy does is basically every 5,000 milliseconds or every 5 seconds, it comes out and publishes a message into the message broker, which is the hello world message. And the hello world message itself actually comes in from the configuration. So if I were to come back over here and look at that, oops, sorry, that's the wrong one. Back down to my samples. Since I didn't pass in a message, it's just going to be hello world, right? So it defaults off to that. But basically, that's what it does. It's just every 5 seconds, it sends that out. So I'm going to back over on the SSH then. If I change into the build folder, I can tell it, hey, go into that samples folder, find the hello world sample, and run hello world sample for me. And then it's going to read that configuration that I give it. So I'm going to tell it the configuration is back up in that source files, and I had this hello world. See if I can get this guy. Oh, sorry. Samples hello world, source, and the one for Linux. There we go. Cool. So this is really exciting. It says, okay, the gateway successfully created itself from JSON, and it's running, and it's going to run until you press enter. This is neat, isn't it? See? Okay, not much happening here. Remember that logger? Behind the scenes, all it's doing is dumping messages into log.txt. We don't see anything. This isn't that exciting. So let me enter to exit it. And if I go in and list the directory then, I said enter to exit, okay. Notice that now there's this log.txt. And if I were to go look at that, woohoo, there's a bunch of hello world messages coming out here. So here's hello world coming through there, right? So these are all those messages coming out. That's it, right? Really exciting. But at least we see it run, right? So the key there is to think about, we had some modules. One module just sent messages out. The other one does nothing but log them to a file. We had a configuration where we could tell the gateway, here's the modules we want you to use. And then the other piece of that was, and I forgot to show you this, the links. So the links say any message that comes from hello world goes into logger. And that's how we build that message pipeline, right, is through these configurations of links down here. And so if I go back and look at that, that's that configuration. All right, so we demoed that. Let's do something a little more involved and actually get messages going up, right? So one of the first problems that you'll have playing around with gateways is that at some point you're going to want to talk to an actual sensor, and that sensor is going to have some hardware communication requirements of its own, right? Do you talk to it over Wi-Fi? Do you talk to it over BLE? Do you talk to it over USB? Do you talk to it over some other, industry protocol or something like that? And so it's going to be upon you to either write the module that knows how to do that communication, or look for a third-party module or one from Microsoft that does it for you. And so a nice way to test out sort of your pipeline without having to worry about the device is to use simulated devices. So in this configuration, I'm going to have 2 simulated devices that are generating messages. We're going to map their IDs, their simulated ID, up to actual device identities up in Azure IoT Hub, and then we'll send those messages up into Azure IoT Hub. So first, let me jump over to my browser. Oops, sorry, that's not it. I should have pulled this up earlier. I'll jump into the Azure portal. Let me get another one going while that one loads. Cool, I might need a few of those. Cool, so in there I have a Azure IoT Hub already created. And if I drill into that Azure IoT Hub, I've already provisioned some devices. So a device in Azure IoT Hub, or device identity, is really a set of credentials. So a device is going to have a unique ID. Think of that as its username. And then it's going to have a unique key. Think of that as its password, right? So in order for something to connect as that device, it needs to know its ID, and it needs to know its key. And so I already have a number of devices pre-configured, but notice I have one that has this beautiful fake hardware address, or device ID, I should say, of just, it looks like a MAC address, but it's just a bunch of ones, right? I made that up. It's simulated. It's just my fake device ID. But there's its ID, and then down here is its primary key, and I know it's kind of hard to tell here, but that ends, not primary key, yeah, primary key, in SVG equals, right? So just don't remember the whole key, just know that it's SVG equals, right? I've got another one over there That one ends in EHW. That's the O2 simulated device, all right? So I've got some simulated devices configured up there. And so now if I go back to VS Code, let's go look at the simulated device sample. And so if I go in here, I've already edited these config files just to keep the time down. But if I look at the one for Linux, this configuration is a little more involved, right? So first of all, I need to be able to tell this gateway if it's going to publish up to the IoT hub. At this point, it would actually go send messages out to the IoT hub over AMQPS or HTTPS or MQTTS. And so in order to do that, the gateway itself needs to know how to connect to the IoT hub with appropriate permissions out there, or at least where the IoT hub is. So I have to tell it, here's the hub name, here's where it's at, and I want you to be able to use, or I want you to use HTTP, remember that really means HTTPS, to communicate with it on the back end. So now it knows where that hub is, so it can send messages. Down here then, I have a couple of modules that simulate a device. And all that thing's going to do is emit some sensor data, constantly incrementing temperature every so often. And here I'm telling it, every 2 seconds, publish a temperature value up and act like this is your MAC address, right? Let's say this was a BLE device, right? So we'll act like that's the MAC address that I'm publishing as. And then I have another one that does the same thing, just uses the other MAC address for me, right? So 2 simulated device modules. Then I have a mapper module, right? So if I go back here and look, the simulated devices both send their messages to this mapping module. And what the mapping module is supposed to do is take the hardware address. Let's take a different scenario. Maybe it wasn't a MAC address. Maybe it's a USB device ID or a COM port or something like that that they're coming in from. So when messages come in from COM1, send up to the cloud as this device. Here's the ID and the key to publish into the IoT hub as, right? And so the mapper is responsible for doing that mapping for me. And so in this case, I see the mapper says, okay, well, when we see a local hardware ID of this, use the device ID in the cloud of this. And notice I purposely made them the same. You could have called the device ID Bob. And says, well, when you see messages from MAC address 11111, send them to the Bob device, right? But that would be a little confusing. So I use the same device ID as the hardware ID, so I know which ones I'm looking at when I'm looking either local or in the cloud. And here's the key. Remember that key ended in SVG? So there's the password for it. So I'm basically saying when you get messages from this device, send them up to the cloud as this device with this password. And then same thing down here for the O2 device, right? And then finally, I have a logger that logs everything out. And then I've got these links that says every message goes to the logger. Anything that comes out of SimDev1 is going to go to the mapping module, so it can get the device ID and key, and then the mapping module will send it up to the IoT hub. Similarly, anything coming out of device 2 will go to mapping, and then mapping will send the device ID and key over to the IoT hub so it can publish the message. Those are what we call device to cloud messages, right? The simulated device is sending the message, and it's going up to the cloud, device to cloud. You could also have cloud to device. It's possible to have a situation where we want to send a message back downstream from the cloud to the device. And so if the IoT hub gets a message in, it'll send it to mapping, so it can turn back around to get the MAC address, and then mapping can send it to my module, so that my module could actually go talk to the device and do something with it, right? Similarly for SimDev2. So if I go back and run this sample, what am I missing? Got one too many. Simulated device cloud upload lin.json. There we go. Cool. So at this point, there's those simulated MAC addresses and temperature sensors, and they should actually be sending data. So that means that I should be getting messages to them up in the IoT hub. But if I want to see those messages, I need a way to monitor the hub, right? They're getting to the cloud. I'm not getting errors. So they should be getting to the cloud. Now I want to see them. So remember, I mentioned that there's SDKs for you to get messages out of the hub on the back end. So I could go write some code to go do that. But there's some tools to help you do that already. So one of them is an extension in VS Code called the Azure IoT Toolkit. So I've already got that guy installed. And then you'll notice that back in my workbench, I've got this panel down here called IoT Hub Devices. And I've already connected it up to my Edge IoT hub in the cloud, but you can always come in and tell it which IoT hub you want to connect to. It then went and found all those sensors, and if I actually come down here, I can see that device that I'd configured, but I can also come up here and tell it to start monitoring device-to-cloud messages. And so I'll turn that on, and then in this panel down here, we'll start to see, sure enough, there's those temperatures, 13, 14, 15, and if I were to pull the command prompt up, I'm at 17, and we should see 17 and then 18 coming through. So I see the messages, right? So they've round-tripped. They've gone from the Pi up to the cloud, and then VS Code's pulling them back down for me on my laptop. Does that make sense? Cool, so we see it working. This is not the best way to monitor these messages, though, so let me just close that guy down. And there's another tool called Device Explorer. This is part of the IoT Hub SDK. You can go get it. But I can tell it to, I've pointed it to that same Edge IoT hub, and I can tell it, hey, just go start monitoring messages from that device. And now I can see those temperatures coming in, 33, 34, et cetera. Right, so now I can verify it. I see it working, and I've got this stuff round tripping, and I should also have sensor data coming up from device 020202 as well. Cool. So at this point then, I've sort of tested. I know how to go in and build a pipeline with the gateway. I know how to get messages in from sensors. In this case, they're just hardwired modules. And then I can ship them up to the cloud and get them up there. So let's take that a little bit further and actually go use BLE. Anybody played around with BLE? Okay. It's Bluetooth Low Energy. It's maintained by the Bluetooth organization as a separate specification underneath Bluetooth 4.2 and later. It's Bluetooth Smart or Bluetooth, well, that's like another marketing name for it. But the idea of Bluetooth Energy was specifically, or sorry, Bluetooth Low Energy, was specifically the low energy part, right? They wanted to build a wireless communication protocol that didn't require a lot of power from the device itself, right? And so it isn't as heavy of a protocol as regular Bluetooth, right? I don't have to go pair with devices and all that kind of stuff. So these little sensor tags here are kind of cool. Again, I mentioned that these things are pre-built by TI with existing data, temperature sensors, humidity sensors, accelerometers, and all that kind of stuff. And if I turn this guy on, it just starts broadcasting. Starts shouting out, hey, here's my MAC address, here's my hardware address, and here's the services I offer. If you want to, you can get my temperature. If you want to, you can get my humidity. If you want to, you can get my accelerometer or my magnetometer or whatever, right? And so it publishes information about these services, and then as a consumer, in this case, that would be my gateway, I just have to go tell it, okay, I want to get the temperature sensor data, please. Enable that service, and then I can start reading those sensor values from it. Make sense? So in this case, the gateway is going to communicate over BLE with this, and then it'll use TCP/IP and AMQPS or HTTPS to ship data up to the cloud for me. So that whole BLE stack stuff, this is where you start getting protocol specific. And so I'm just using BLE as an example. You'll find that you're going to have a similar process that you'll go through with really any other sort of device protocol, right? Be it Modbus or CAN bus or Wi-Fi or roll your own or whatever, right? And so the way that Bluetooth Low Energy communicates is with a couple of specifications, one called GAP and one called GAT. So GAP is the generic access protocol, and then the GAT is the generic attribute protocol. So GAP controls how we connect or how we decide to communicate, and then GAT decides what are we going to say when we do, right? Sort of what is the data and how do we make that work. So this is really fun. I spent probably a couple of months digging into BLE over the summer, and you get to look at fun stuff like this. It's really neat. You know, it's just nice reading at night. Et cetera. But the BLE specification has a number of well-known services, right? So if you have a Fitbit, it's got a heart rate sensor service, right? Or a heart rate service. Or almost all these guys have a battery service, right? And so those are well-known services. And so you, as a BLE consumer, could write code to talk to anything that has a BLE or a battery service on it. and you know how to talk to that battery service, right? It's consistently implemented across devices. You can also have custom services and custom profiles that have nothing to do with anything anybody else has ever done, and you get to make your own up. And so TI has done that with its things, and so these services all start with this big, long, funky GUID, and then they just customize the 4 characters in there for the different pieces of it. And so if I look at this, up at the top, I have a primary service declaration, and I know it's really small to see, but for the IR temperature service. And so that lets anybody know that queries it, oh, there's a IR temperature service on this device. And then down here are the things that I might want to get from it. So I can ask for the actual temperature data, I can configure it, I can tell it to send me notifications or not. But if I look at this characteristic down here, notice there's this GUID of the AA01, that fits right into those 4 characters up there. And that's where I would actually pull back the temperature data. All right, so I get down, now I know the ID. It would be this GUID with AA01 to actually read the temperature data. However, to do that, I also have to go in and turn on the sensor. And I guess I deleted the slide where I highlighted that, so that's my bad. So anyhow, it's just kind of important to understand those. And you'll need to know those GAT services and GAT IDs for the device you want to communicate with. Did I lose my, no, I'm back. Let's go back here to the BLE sample. So I'm going to deal with sensor tag 01 and sensor tag 02. These guys look identical. I just put 2 zip ties on one and 1 zip tie on the other, so I know which one's which. So this is my sensor tag 2, right? And it has an actual MAC address. And so there's a number of Bluetooth tools that you could use to go scan them. There's ones that you can download for your phone, and it'll help you find devices that are nearby. But from them, you can get, the MAC address of this device. And then you can also pull back what services it publishes and all that kind of stuff if you want to from there. But so here's my configuration for this gateway implementation down here. And so I set up a device called sensor tag 02, and I tell it that that guy is going to be this BLE module, this libBLE. And so that's going to be what actually communicates over BLE with this device here for me. And then I've got to tell it some things about how to do that communication. So in the arguments of that module, I tell it what is that device's MAC address, right? And so I went in and found the actual MAC address, and on the slides, I give you a link up to a walkthrough in our portal, or in our documentation, that sort of walks you through how you could do all this stuff. So if you want to go get an actual TI sensor tag, this documentation will walk you through how to do it, and you can find out how to get your MAC address and all that good stuff. Again, just in the interest of time, I'm going to pass on that for now. But if I come back over here, I've got the MAC address, and now I have all those different GAT characteristics. So I have some that I'm going to tell it to read just once. And that's as it starts up, I want you to go read this GAT value or this GAT value. And so these ones are well-known ones. Notice they don't start with a big ugly FF or F whatever. These ones are going to be things like the model number and the serial number and the manufacturer name and that kind of stuff, right? So this is just generic information about the device. We don't need to keep reading that, so we tell the module just to read it one time at startup. I have some other ones in here. This one is right at init. And what this one's going to do is basically go in and turn on the temperature sensor. It says, hey, yes, I want to read your temperature sensor value. So I have to send it a message that tells it to go turn on the temperature sensor. And then you might remember I showed you the AA01. That's the actual temperature sensor value. We're going to read that periodically every 1 second. So every 1 second, we're going to go over and say, okay, what is the temperature? What is the temperature? What is the temperature? Does that make sense? And then finally, when we exit out, we want to go back to that one where we told it to turn on the temperature sensor, and we're going to tell it to turn it back off, right? And so that sends a message back down and says, okay, stop publishing, quit wasting your battery, stop sending me, or stop tracking temperature sensor data for me. Cool? So that's my module to talk to the BLE. And then similarly, I've got a mapping module that's going to help me map that back up. And it says whenever we see messages coming in from that MAC address, up in the IoT hub, send them as the sensor tag device with this ID, right? And those are devices that are over in the IoT hub that I showed you earlier. We've got a BLE printer that does nothing but log it out to the console for me. That's like the logger that we had before. And then I have another one that can take messages from the cloud and send them back down to the device. So you can't really see it at all on this, but there's some LEDs on the back of this guy. They're not on right now. There's a green one, there's a red one, there's also a buzzer, right? And so if I can send it a message that says like, hey, turn your buzzer on, this guy will buzz, or turn on your red LED, or turn on your green LED. So those are messages I can send or write to the device. And so it's possible then for me to say, well, hey, if I get a message in from the cloud, maybe it would be the GAT characteristic and the value that I want you to write, I could turn around and write that back down to the device itself. So this module implements that back channel for me. So if I jump back over here, cool. So that's the BLE gateway implementation, and I'll give it the sample file that I wanted to run, that one that I was just looking at. And what one was that? Gateway Brett sensor tag 02. JSON. Cool. All right, now to do this, I've got to turn on the sensor. Cool. And you can see it communicated. Remember those read onces at the beginning? Those are those ones that just scrolled by there at the top. Sorry, they went off screen, but it was manufacturer number, serial number, that kind of stuff. So it actually read those from the BLE. Now these messages that you're getting through here we'll come back to it, but I have a function running in Azure that's periodically sending messages down to the sensor tag, telling it to turn off its buzzer and LEDs. And I'll show you those functions there in a minute. But I think every 10 seconds or so, I think that's how often it sends it, you'll see a bunch of messages fly by. And the reason those are happening, oh, maybe not. Well, we'll make them work. Okay. We'll see those in a minute. But anyhow, it looks like it's sending data up. Now, if I jump back to the slide, in fact, this thing says that when you get temperature data, it's going to come back as the object least significant, most significant bit, ambient lowest or least significant, and ambient most significant bit. You get this basically 4-byte value that is ugly, and you have to go parse it out and configure it or do something with that data. I'm not doing any parsing of that data right now. It's just shipping it straight up to the cloud. So if I go back over to that Device Explorer, I can tell it to monitor that sensor tag 02 device for me. There we go. So I'm seeing some values come up, and they're not pretty values. I was hoping they'd be even uglier, though. Cool. All right. Well, let me zoom in on this. And so this is the actual data value. It looks like a number. It's not. Usually it's funky symbols like a diamond and a square or something. I wish it looked uglier because this makes it think I'm getting a number. I'm not. Those are just useless characters, right? The temperature is not 4 right now. So this is just that binary data being represented as ASCII, right? It's trying to show me the characters from that binary data, and it just doesn't make any sense. So I need to modify my configuration. And so what I want to do is go add in a module. And so I've pre-built a module here. I creatively called it my module. You can call it something else if you want. And inside there, this is the ANSI C99 stuff. So how many of you guys do C++ development on a regular basis? Okay, not many hands go up, right? And so this, I think, for me was sort of one of the first daunting things about getting into IoT Edge as it was in V1 with the packages out there, is that I don't write C a lot. And so I kind of had to figure this stuff out from the beginning. But basically, this guy's going to come in, and it's going to go get that message out for me, and then we'll go generate a new JSON payload that has those values that we've parsed out, right? So, in fact, this one's hard coding sensor tag 01. Don't worry about it. This message doesn't actually really matter at all. It's just a sample payload, but we send up the actual temperature in this JSON payload. And then the other thing that I'm doing is I'm testing to see if that temperature is greater than 30, then we're going to set an additional property on this message called temperature alert, right? And that's going to go up to the IoT hub, and I'll show you what I can do with that in a minute here. But basically, this guy's taking that data in, that ugly binary data, turning it into a nice JSON payload, adding some properties on it based on the quality or the values in the messages, and then sending them back out downstream for me. So once you do that, you have to go in and recompile your gateway. I've already done that again, just because it can take 5 or 10 minutes to go through the compilation process. But if I come back here, then I've got another configuration. Let me exit out of this. Down there in the samples, that has that conversion module in it. And so I've just added in a reference, right? And it's going to go load that module up for me. And then we say, as the sensor tag, and send it off to my module, right? And that'll do the conversion, and then the module sends it off to mapping, and the rest of the pipeline continues. Cool? So I've just kind of injected that into the middle of my message flow here. So if I come back and run this again, conversion. Oh, man, going slow. To.json. Cool. All right, so this guy's running. And notice now, those are those JSON strings that are coming out. And again, I messed up in my source code. I have it hard-coded. It's sending this string that says sensor tag 01. Nothing's ever really looking at that string, though. It's just a sample payload. So ignore that it says sensor tag 01 in there. But do notice that the temperature down here is at 24, right? And so if I actually take my hand and wrap it up around we see that temperature going up, right? So it got up over 30 and stuff like that. These other messages that we see flying through here are related to messages coming back down from the cloud. So let me go explain those. But first, let's go back and look at the sensor data now that's coming up into the cloud. And notice they're much nicer messages. There's that nice JSON data coming in. Make sense? So I've stuck that little conversion module in, added some value to the data, and now we're shipping it up, and I'm able to get the actual temperature values coming back out. So there's like a 19.25 and other ones coming in there. Cool. So the other piece of this then is, we talked about actions, doing something with the data that we get up into the cloud. And so Azure functions are a really great way to run pieces of code, right? I don't want to go set up a whole VM. I don't have to go build a full-fledged web API or something like that. I just have some code that I want to run if I get a high temperature, right? Well, I already know when I have a high temperature because that module is adding a property to my message that says it's a temperature alert if it goes over 30, right? And so IoT Hubs has this really cool feature called routes. So let me get back to my portal. And inside the IoT Hub, if I come down to endpoints, I've created a new endpoint that's going to point off to this other event hub that I went ahead and created. Now, event hubs are just another messaging service that we have inside Azure. They're a high-volume mass ingestion service, but they're a great way to act as a middleman between sort of layers in your application tiers, right? So if you've ever used queues or things like that to sort of build loosely coupled service architectures, Event Hub is sort of the du jour, hot or cool kid service to use for that. And so basically, I've set up an endpoint that's going to receive messages just when they're an alert. And the way I make those messages get there is I set up a route. And the route is going to look at the messages that are coming in from the IoT Hub. It's going to look for a property on those messages called temperature alert. And if the value is true, we match the rule, and we'll forward the message off to that other route. Make sense? Or off to that event hub. So then I've got some functions. Anybody play with Azure Functions? Super cool stuff, right? You can write them in Node or C# or PHP or sort of pick your language, Bash, PowerShell. But I've got a couple of them up here. And this first one is my alert function. And this one is going to get triggered whenever a message shows up into that alerts event hub for me. So this code automatically kicks off. This is awesome, right? I don't need to schedule it. And so basically what it's going to do is go look, and the code's a little grayed out here, but basically it's going to go in and configure a message to send back down to the device. This one's going to tell it write once. Let me zoom in a little bit more. We're going to write once. Okay, I got to find the code. Try that one more time. There we go. Write once to this GUID down here, some funky string. And what that's going to do is basically turn on the red LED for me. Cool, so that's a write message that's going to come from the cloud, back down through my gateway, back over BLE, down to my sensor tag with this BLE C to D thing here. The problem is that then my red LED turns on, and it never turns off, right? So I have another function that runs just on a timer. This guy runs every 10 seconds and just automatically sends a message down, to the thing that just does the same write once to the same thing, but it sends it a value to turn the LED back off, right? And that way I can wait for another alert to come down. So if I jump back over here to the first one and log it, we can see the execution of it down here happen. I've got the gateway running down here. My temperatures right now are at about 20. So let me just hold over. Oh, we're up over 30. We already know it triggered because I'm getting funky messages back. But if I go back to the portal, I can see down here that the function completed, right? So it wired it, and it's sending the messages back down here for me. Now, the other one already fired off to turn it back off. So let me do it again. See the LED on the back of that? And if I hold it up there long enough, the other function is going to run that turns it back off. Cool? Make sense? I don't know. I think that's really cool. It's just an LED, but a lot of stuff went into getting that thing to turn on, right? So I have this guy talking over BLE to my Pi. My Pi is pulling those messages off BLE, sending them through a conversion module that figures out if it should be an alert, ships it up over IoT hubs, which says, oh, look, it is an alert, sends it off to an event hub, which triggers the function, which fires the message back down through the IoT hub to my gateway, over the modules, back to BLE, over to the sensor tag, and turns on the LED. Right? And then we have the other one that's the timer function that does the same thing. And if you talk about it like that, it sounds really complicated, but looking at the pieces, we kind of see where everything fell in. Does that make sense? Cool? All right. So I got a little ahead of myself, but that was that demo. So those modules are extensible. I showed you that I went in and created my own module, and then you can compile those and get them mixed into your gateway configuration. You don't have to write them in C99. You can write them in .NET. You can write them in Node. You can write them in Java. And we have loaders that are part of the runtime SDK that you can use to pull in modules written in other languages. And again, you can learn all the documentation up at the IoT Edge GitHub repo. I also mentioned, though, that there's some modules or things to help you get kickstarted with development in, say, Node if you don't want to mess around with that C99 stuff at all. And so let me go show you that here really quick. Yeah, I'll pull it up in the browser here first. So this is under Azure Samples, IoT Edge Samples. And we have them in there for Java and JavaScript and .NET Core and .NET Full. So you can go read up the documentation on how to get these guys working. But basically it says, hey, look, if you're on Raspbian, you can just go clone this repo. So I think my Wi-Fi is good enough. I'll go ahead and try it here really quick. Let's get out of this one. I'll go back up to my user folder, my home folder, and I'll do a git clone, https github.com, Azure-samples, IoT Edge, samples, and I'll clone it into another folder because I already have a copy of it here. I'll just call it demo. All right, so I can go into that demo folder now, and I see I've got a folder structure in there. Let's go open that up in VS Code. I love that Samba config. It makes it so much nicer to work on code that's over there than having to try and do nano or that kind of stuff, or run an editor through VNC. All right, so there it is. So in this JavaScript folder then, they give us a couple of samples. This simple sample here, though, has this app.js. And so this is where the gateway itself actually gets spun up. Well, in fact, before I look at that, let me come down to package.json, and you'll notice that we have a dependency on the Azure IoT gateway, as well as, in this case, we're using AMQPS instead of HTTPS or MQTTS to communicate. So we pull the protocol down that we want to use to communicate with the gateway. But this one right here, this is that pre-compiled gateway from the C99 source code, just stuck into a nice little package that I can just now download through NPM, and it shows up in a subfolder underneath node modules. And I'm not having to go do CMakes or builds or anything. It's just pre-built for me. And we get them for Windows and for Mac OS and for Debian and that kind of stuff, so I can run it on my Pi without any issues. Cool. And so then I have this app that does nothing but basically pull open the gateway and tell it to read the configuration file and go for it. So it's really easy to use. And then I have some modules, and the modules now are nicely written just in JavaScript. So I have a module here called sensor. It's a simulated sensor. Sorry, let me close that up. And so if you're a JavaScript developer, hopefully this code looks a little bit nicer than the C99 code that we had here before. But basically, our modules are going to have a few different things here. I have a function that will get called by the gateway when the module is created. And so any initialization code that you need to run, you can set up in here. I've got a broker object that I can use, and that's how I publish messages to the broker. I've got a function that the gateway calls called start. And so this is where you actually kick off whatever it is that you want your module to do while it's running. And in this case, you'll notice that it uses the broker to periodically publish out a message, looks like once every 500 milliseconds. And then I have some helper functions, and then I have a message that runs whenever the gateway sends it a message. So this is if you were going to receive a message, this is where you would go do something with that message, and there's the message. And then finally, as the gateway shuts you down, it'll call your destroy function for you, and you can go implement that code. A lot nicer to look at than the C99 code, but it's doing the exact same thing as the C99 code. If you went back and looked at my module or any of the other modules I quickly showed you the source code for, you'd see similar methods for the Gateway API inside those as well, right? So there's that nice little sensor, and then I have another one called printer that just does nothing more than console log the message that it receives out to the console for me, right? So pretty easy to use. All I had to do was clone it. And so now I can go down here to JS, simple. Oh my goodness. Apparently my Wi-Fi is slow enough that it's hard to type over SSH. There we go. All right. And so I'll just do a node run local. Sure I will. All right. Oop. Oh, I didn't do an npm install. So I got to do an npm install. And in fact, I'll tell you what, you saw how to pull it down. I'm going to go back. I already have a copy of this downloaded. All right, node run local. Gotta love demos, don't you? Oh, sorry, npm run local. I'm a goofball. All right, so this guy kicks off, starts running, and I can see it now pushing sensor data up. Well, it's not really pushing sensor data up because, remember I used the word local there? If I look in the configuration file, there's no actual IoT hub module. It's not actually publishing anything anywhere. So let me, in fact, go change that. Boy, nice small font. Come on. Cool. And so in there, I've already configured, in fact, while that loads, back over here in the portal, you'll notice that I have a device already set up for my node gateway. So this is another pattern that you may find, right? So originally, remember, I had a device ID for every device that was going to communicate through the gateway. You might not need that detail. You might instead decide to treat this guy like the device. This guy's just going to connect as itself and then publish a payload that tells it the different sensor values that it's read, right? So this is kind of that pattern. You don't have to do it that way. This is just the way this sample was. But I've got this node gateway device up here. And if I go back to my code, you'll notice then, there we go. This one is going to use this IoT Hub Writer module now, and it tells it to go connect up to the hub as that node gateway device ID with its password, et cetera, right? So it's going to connect as that. So let's go back here, and I'll try to run this. Now, I was having a little bit of a bug on this earlier. Let's do an npm run. If I do cloud this time, it'll use that config. Something going on with like the AMQP library or something where sometimes, yeah, it's doing this v8 to local checked. And this is just, I'm not sure exactly what's going on. Let's see if I can get it to kickstart here. And if I run it a few times and it fails, at this point you've seen messages go up to the cloud, so. Yeah, give it one more try here. I almost thought it was going. All right, it's all right. You saw the messages going up before. I'm hitting an issue, and I'm not sure exactly where it is. It's something to do with the node and the V8 engine, and I think it's in the AMQP library where it's got to like catch it right, and then it'll start sending. But all we would see now is the messages going up into Azure. So that's a solvable problem. I just haven't had time to figure out exactly what's going on there. And like I say, if I run it enough times, eventually it'll catch and actually start sending the data up to the cloud here for me. So interest of time, I'm going to hold off on messing with that anymore, though. But at least we see the development process was a lot simpler. Right? I just go and I write some node modules, and things are a little bit easier there. So I promised I would talk a little bit about Azure IoT Edge v2. So at this point, really what you see then is that the gateway runtime itself provides some core services, right? It provides this messaging pipeline, and it provides a routing service to be able to get messages between modules and that kind of stuff. It'll have a configuration so it knows what modules it needs to load up. It would be nice to have some other services built into it as well. Like I had to pull in a module to teach it how to talk to the IoT hub. It'd be nice if it had built-in capabilities to just publish up to the hub. Is anybody in love with the JSON configuration files yet? Okay, maybe not. It's kind of a painful configuration model right now with v1.2, right? Where I basically am having to SSH into the device to get to this JSON configuration file. I'm having to hard code MAC addresses and all that kind of stuff in there. So the configuration story could be improved as well. And so v2 aims to try and solve a lot of those different problems for us. So there's a couple of different scenarios here, right? So the Edge runtime itself is just like we saw right now with v1, although now what it is a Docker container. So we're basically going to run a Docker container that pulls down the Edge runtime and implements an API that's compatible with IoT hubs. And so the modules, rather than using this nano message broker, are instead going to send messages to and from the gateway, just like it thought the gateway was an IoT hub. So we use basically an extended version of the device client for IoT hubs to communicate with the gateway itself, which is really cool. Keeps things a little more consistent. The devices then, again, can send messages in over protocols like BLE or whatever, and so we can create a module then that can go in and read that. We have security built into this, a whole bunch of stuff around the security of the runtime itself, where code can get injected and a bunch of other cool stuff there. multiplexing. We're using AMQPS on the outbound, so we can actually send multiple messages through a single connection to try and cut down on the amount of session traffic that we have to generate. Store and forward offline. So we have proposed scenarios where, what if the IoT Edge Gateway gets disconnected? You know, and sensors are sending data in. I need a place to sort of cache that sensor data until the connection can come back online. So we're looking for support around that stuff. And then management for devices otherwise isolated from the internet. And that's kind of what I had here, but it'd be nice if I could provide the configuration for this device in the cloud and have that come down to the device rather than me having to edit some config file locally for that. So those modules then really just become Docker container. Sorry, I'm trying to get to my animation here. All right, there we go. So imagine that I've got ML running up in the cloud or something like that. I've got telemetry coming in. I've got a module that knows how to talk, say, BLE. It can then do some formatting just like I did where I converted the message coming in and then ship it up to the Edge runtime and then in the cloud do some machine learning or something like that. Then I could turn around and use things like Azure functions to invoke data, et cetera there. But those modules then, that protocol ingestion, those data formatting modules are themselves just other Docker containers. And the cool thing about that is, again, I talked about being able to run this across platforms. It's that sort of, it's running in a Docker container. It should work on, if it works on your box, it should work on another box. I think you'll find some issues there, certainly because we're starting to talk about hardware stacks. So the way I talk to BLE is going to be different on Linux than it is on Windows, et cetera. But inside the Docker container itself, it's all Linux. And so I've got some consistency there. So cloud offload is another possibility that we look for here. Where we can start to, for example, pull that ML down onto the edge itself. And so the team is hoping to provide a couple of modules. I'm not part of the IoT Edge team, so I'm speaking on their behalf. If you saw their Ignite presentation, they talked about no promises there, but to have stream analytics analog, machine learning analog, and I think an Azure function analog that you could run on the gateway device itself instead of having to run up in the cloud. And so the other cool thing then is if you look at those modules like the ingest or the conversion or the ML modules, those can basically be Docker containers sitting in cloud-based repositories. I can now then come in and create a configuration for my gateway in the cloud. That configuration then can be pulled down to the gateway itself and tell it, here's the module I want you to go get, and it can then download those modules. I now then can update the configuration in the cloud, redeploy it, and it can change which modules it downloads and executes for us. So we have a much easier way of configuring which modules are running and how they're connected and all that kind of stuff. So looking forward to it. That stuff, again, I think they're talking about trying to have a public preview of IoT Edge v2 before the end of the year, so keep your eyes out for that. Hopefully they can get that in. So with that, hopefully that gave you a good overview of sort of Azure IoT Edge. We talked about the Azure IoT stack, came back in, looked at sort of the existing available version of IoT Edge with v1, and then what's hopefully coming down the pike with v2 there. If you're thinking about getting started, I think there's still a lot of good learning if you went ahead and started with v1 now. Because again, the concepts of what you want to do with the messages isn't going to change at all as you go to v2, right? The things that you want to do with the gateway are consistent. And in fact, a lot of that code will probably apply over to v2 as well. But then certainly keep your eyes out for the v2 stuff. So with that, I think we're pretty much at about time. So I'll wrap things up. I'll hang out here if you have questions. I'm also in this room after lunch looking at Electron. So if you're interested in that, come on back and see me. Thanks for your time, guys.